No, one more mathematical way I'll bring it. This is what A normal, no? This is A normal. What about tangential? This is a tangential. And this is the total acceleration vector. And it will also have velocity. It will also have tangent. Instead of writing v theta, let me write only v. Where alpha and omega will be? The sense of rotation like this, no? So is it justified? These are not directions of alpha and omega. What they are? Just this arrow is sense of rotation. How omega and alpha will be out of the plane. Okay, got the idea, no? Now I want to write relation between A naught, AN and V, only in terms of that. A tangential. Okay, total acceleration vector. A tangential, I know total acceleration vector and the velocity, that's all. A normal in terms of A and V. A theta in terms of A and B. So what is this angle? This angle is equal to beta. Angle between tangential velocity and total acceleration. So let's do one thing. A bar and A bar dot V bar. Let me take dot product. A bar dot V bar. So what it is equal to AV cos beta. Will I agree the dot product? Tell me like what is A theta equal to? Can you write A cos beta? So in place of A cos beta, what shall I write? A theta. So what is A tangential? A tangential bar should be equal to A bar dot V bar by magnitude this one, or this will be only magnitude, no? This is. Very important for you. If you know total acceleration and tangential velocity, you can calculate. You can calculate what? Tangential acceleration. Okay, similarly, let me take cross product. A bar cross V bar. This is equal to AV sine beta. What is A normal? A normal is what? A sine beta. So this A sine beta, I can write it as A normal into V. So what is A normal is equal to? Or in the vector form, okay, got this. So there is another vector form. Suppose if you know one quantities, you can bring the other quantities here. I'm just showing the different things here. So I think you might have confused really a lot. Okay, let it be, no problem. So here again, what are the some relationships? What we know? We know V equal to R omega. We know some things. Let's write them. And A theta equal to R tangential acceleration R alpha. And what is A normal? A normal equal to omega square R. Or V into omega, or V square by R. Or this tangential R and alpha is what? D omega by dt. And what is A tangential? A tangential is rate of change of speed. Huh? So only just you should be familiar with the symbols here. So this is a one thing. Okay, now I'll show you still more easier one. Huh? Still more easier one. We know V equal to omega cross R bar. Let me differentiate this. You will be surprised to see the way I'm bringing so many methods here. R bar cross d omega bar by dt. Tell me what is dr by dt? You can write it v bar. And what is d omega by dt? Just now I wrote it alpha bar. What is dv bar by dt? Total acceleration vector. So omega cross v plus r bar cross alpha bar. What is this? This is the centripetal acceleration, no? Okay, this quantity, another form. This is what? Centripetal, and this is what? This is what? The tangential. So there's a way of showing in the vector form. So you do come across the various types of numericals and different situations. If they give vector form, so these are the different ways of expressing things. So what is A normal? Can you also write in vector form? What is A normal? Omega cross V, you have to take it. So what is the direction of A normal here like this? Alpha is out of the plane. You can check it. Omega cross V. Omega cross V. If you check it that, it'll be directed along AN. So shall I write the formulas like this? AN is equal to what? Omega cross V. A tangential is what? R bar cross alpha bar. Get this one? So these are the different ways of expressing the circular motion. So if I don't introduce them, numericals what happen, you do come across things like this. They give omega and V, omega bar and V bar. So once you know omega bar, V bar, S, you can bring the tangential acceleration. If they give R bar and alpha bar, from that you can bring the tangential acceleration. If they give omega bar, V bar, you get normal acceleration. Sir, which one to follow? You have given us so many things. I suggest you stick on to this particular thing. This is something very important. And non-uniform circular motion. These two. So these two are, I just put tick mark. So it'll be, please look at this. I'm writing. So these two what will happen, the discussion will help you a lot. The remaining all what happen are maths based. They will help in numericals. But to understand concept, you have to focus on these things. The content here. The other things are just it's a when non-uniform circular motion. I think I'll take it out. This also will be very difficult for you because here mathematics I brought it. No? Okay, got this. So this is the one thing, and this is the one thing. So when you are referring notes, no, so just put effort here. The remaining all will help us in numericals. When any some three-dimensional circular motion comes, there what happens? This method will help us a lot. Fine, all of you. This will be useful only when three-dimensional one or curvilinear motion. For circular motion, so what all we discuss problems, so maximum will be focused on this content. Okay, this is all mathematics. Just like when the three-dimensional motion comes, so this is going to help us a lot. Non-uniform circular motion. I please look at this. I shaded at 2 points. So only you have to take help of these two contents. Remaining all mathematics, as and when numerical comes, you can see the use of that. But the what all the 90% of our numerical solving just revolves around that. So if you're going for Olympiad, no, the first method is will going to help you a lot. Some three-dimensional motions we discussed there. The first method is going to help you a lot. Any doubt you can clarify? If you are confused with the first one, stick on to this, the two things which I shaded. Yes, anybody?
Sir, here we defined centripetal acceleration to be acceleration due to change in direction of motion, right?
Yeah. Centripetal acceleration is purely due to change in direction of motion. It's over. Particle moves with a constant speed, sir. How it will have acceleration? Due to change in direction of motion. Velocity constant, no acceleration will be there. But here what I'm saying, speed constant, but direction is moving. No, if it moves in circular path with a constant speed, direction of motion changes. And according to definition, a particle is said to be accelerated when speed changes, direction changes, or both. So in uniform circular motion, what's happening? Direction is varying. So because of that, there'll be central acceleration, and I will be directed towards center, not away from center. This is the core idea. See, I'm telling this one. What all today I thought you forget everything. I'll not scold you, but you should not. What I put the diagram. This is what the core of our chapter. Centripetal acceleration is due to change in direction of motion and will be directed towards the center of arc. Circular motion I'm saying, so center of circle. If any curved path comes, it is directed towards the center of the path or
Okay.
center of curvature. Is anybody? This is something here you can see diagram, no? So this is also very important for you. Look at AN. Okay, go this one. Okay, let me just okay give. There are again two types of just small diagrams. So then I'll wind up. Now increasing speed, decreasing speed will take it. Speed increasing.